So what I can look at here is I have a balanced equation, 2 hydrogen plus oxygen yields 2 water. And note that we are looking at these all in the gas phase. We'll talk in just a second about how we deal when we don't have everything in the gas phase. Here we're looking at water as our product, and I raise it to the second power because my coefficient is 2. On the denominator, I have hydrogen as a reactant, again, raised to the coefficient of the power of 2 because its coefficient is 2, and oxygen, and it doesn't have a power because its coefficient is 1. So now what I have is an equilibrium constant calculation, or my law of mass action for this particular reaction. And given some information about either the value of K or the value of concentrations of water, hydrogen, and or oxygen, I could figure out an unknown value. Now, when we get to solids, we actually omit them from our equilibrium expression because the concentration of a solid is constant. As I increase the amount of solid, I'm also increasing the moles and I'm increasing the volume by a proportional amount. And so since the concentration is constant, we exclude that from our equilibrium expression, or our law of mass action. Now, when I look at the reaction below, I see I have a solid as a reactant, and I have 2 gases as the product. I can still write a law of mass action, but it's only going to include those non-solid substances. So here's an example. I have 2 carbon monoxide going to carbon dioxide plus carbon solid. In this case, my solid is one of my products, and I don't include that in the equilibrium expression. I write the concentration of CO2, again, no power because my coefficient is 1, over the concentration of carbon monoxide to the second power because my coefficient is 2. Note also that I've added a subscript here to the K value, and so C stands for concentration. Because one thing we're going to look at as we talk about equilibrium is the fact that we can talk about the equilibrium constant with respect to concentration, or the equilibrium constant with respect to the pressure of any gases present. When we're dealing with gases, we can use either Kc or Kp. We do need to indicate which one we're calculating because the values can be different. The other thing I exclude from my law of mass action is for pure liquids. Again, just like with solids, the concentration of pure liquids does not change. So we have a reaction here, 2H2O2 going to oxygen and water, so the decomposition of hydrogen peroxide. And when I look at my law of mass action, I have my oxygen as a product. I notice that water, because it's a pure liquid, is omitted. On the bottom, I have H2O2 to the second power for the coefficient there. And note that this is aqueous. Remember that aqueous means it's dissolved in water. It's a solution. And so I do include that in my law of mass action. So the only thing I omit are solids and my pure liquids. I've assembled my law of mass action. I can use that information to calculate the equilibrium constant. Now, the value of that equilibrium constant can tell me something about whether products are favored or whether reactants are favored. If I have a value of K much, much greater than 1, one thing I can look at is to remember that I have products over reactants. And so if I have a value that's greater than 1, what that tells me is the concentration of the products is going to be much greater than the concentration of the reactants. I don't know how far the reaction is going to proceed to form products, but the fact that it's greater than 1 tells me I'm going to have more products than reactants present. The reverse is also true. When I look at a K value much, much less than 1, I can see that reactants are favored. Here, again, I have my products on the top, my reactants on the bottom, and if this number is much, much less than 1, that tells me the numerator is a much smaller number than the denominator, and therefore that shows that my reactants are going to be the predominant species, and what we see is that, in fact, we have a little bit of product forming here, but predominantly what's present in this mixture is the reactant. Now, every reaction has its own K value, and that can be affected by a variety of factors. What we're worried about right now is how can I set up the law of mass action? How can I calculate the value of K?